Today, guys, we're going to be talking about equations, and more specifically, solving equations. So I just want to start with the basics. What does it mean to solve an equation? You have no doubt solved countless equations in your life, and I just wonder if you ever thought about what you were actually doing. To solve an equation means to find the value. I'll put values with a possible S on the end, because sometimes equations have more than one correct answer. But we're going to find the values that make the statement true. Okay, we're looking for the value of the unknowns. You know, traditionally we use X a lot of the times. It doesn't have to be X, but we'll just start with a basic. Just a linear equation. 2x plus 1 equals 7. Now, we talked a little bit about the difference between expressions and equations in the last video. This is an equation because it has an equal sign, all right? And the x is the unknown, all right? X is not a variable here. X doesn't vary. X is an unknown. So we follow whatever steps, and there are different types of equations, and this is an equation that I know you can solve very quickly. We do to one side what we do to the other. You don't have to write these steps every time, but we get 2x equals 6, divide by 2, x equals 3. Now, just again, to emphasize this point, we found the values that make it true. 3 can go here and give us a true statement. Any other number you put in there is not going to give you a true statement. If you put in 4, you get 9 on the left and 7 on the right. So I want you to start, not only having the skills to solve equations, but start to keep in mind what's really going on. You're finding the values that make it true. Okay, so now let's talk about some of the types of equations that you will be asked to solve in this section. Okay, let's start with something like this. All right, so this is an example of a quadratic equation. It's a very simple quadratic, but this exponent of 2 up here, makes it quadratic. We call power of 2, or an exponent of 2, quadratic. So we need all the values that make it true. And the reason I bring this one up is because this sometimes can lead to mistakes. The thing you need to do to both sides is square root. If you've got a square, you need to square root. However, don't forget, when you square root both sides, technically we need a plus or minus over here. All right, plus or minus 3, because our original equation, x squared equals 9, there are 2 possible values that make that one true. So when you solve an equation, you're finding all solutions, or the solution set. You might see the answer written like this in your answer keys for your odd problems. That might look like that. I don't mind if you write x is plus or minus 3. What I need you to do is convey that you knew that 3 and negative 3 were both answers to that question. All right, let's talk about one like this. How about x minus 4 times 2x plus 6 equals 0. This is a class of equations that you will solve a lot of this year, and these are equations that have multiplication equal to 0. Just as a little side note, if I ask you what's 17 times 6.3 times 14 times 22 times 18.01, you probably don't know that answer right off the top of your head. But what if I throw a times 0 in? Well, if you throw a times 0 in the list, then the answer is 0, because anything times 0 is 0. So my point is, if you've got multiplication of 2 parts, and that's equal to 0, if either of those parts is 0, then the whole thing is 0. So the way we're going to solve this is we're going to take each part and separately set it equal to 0. All right, this is another case where we have more than one possible answer, because if either part is 0, then the whole thing is 0. So here we get x is 4. Here we get 2x is -6, so x is -3. So we could write it either 2 separate x equals or something like that. Now, in our book, since we've been talking about number sets, there's a possibility that the question will look something like this. It will say, solve the equation in the indicated domain. It'll give you the problem, and then it will give you something like this. It'll list one of our number sets, like positive numbers, at the end. A good example where this would happen is, what if this equation modeled something in the real world where negative numbers were impossible, like the height of a thrown ball over a certain amount of time? -3 doesn't make any sense, so 4 would be the only one that worked. So that's just kind of an application of this, but if that's the case, we get done solving this problem, and we're just going to throw out the -3, and our answer is going to be 4. All right, if they just give you the question, then the answer is -3 and 4. But if they restrict the domain, a domain is all possible x values, then you just throw out the answers that don't apply. Okay, so we have one more main category of equations to talk about. Our good old friend, the absolute value symbol. That can throw a little bit of confusion into the mix from time to time. So let's just review what an absolute value is. An absolute value, you probably know, it always turns positive. If you put a negative number inside the little bars, it turns positive. If you put a positive number, it stays positive. You can think of it as distance from 0 on a number line. You know, if I go out my door and I run 5 miles to the left and I run 5 miles to the right, I still got a 5-mile run. It didn't, it didn't make me that much, I didn't burn negative calories because I ran left, because I ran right. It's, all I care about in that situation is how far I ran. There was no distance involved. So distance from 0 is a way to think of it. Just starting with the basics, remember, we're solving equations. If I give you the absolute value of x equals 5, think about any possible values of x that would make that true. If x equals 5, does it work? Sure, that does. The absolute value of 5 is 5. X could also be -5. So basically what's going to happen is, in these equations, we're going to add one more option that's from the negative version. Graphically speaking, I don't know how much you know about absolute value graphs, but they're V's. Maybe the V looks like this. Well, where does that cross the axis? Here and here at 2 places. Same thing with quadratics. The reason that quadratics sometimes give us 2 answers is because they're functions, but they're not, they don't pass what's called a horizontal line test, meaning you could have 2 values when you move left to right in some of these graphs. So that's just a little connection to graphs, but let's get to solving. Okay, so what about 9x minus 17 equals 1? Absolute value of 9x minus 17 equals 1. So think about this. What I like to do is ignore what's inside. Ignore what's inside the absolute value systems and just think, whatever that is, if its absolute value is 1, then this is going to be true. So one of 2 things can be happening. Everything in there can either be 1 or -1. If 9x minus 17 equals 1, are we still fine? Yeah, we're good, because if 9x minus 17 is positive, which 1 is, then the absolute value symbols might as well not even be there. Okay? What if 9x minus 17 equals -1? That's also going to work, because we get the negative turned into a positive because of the symbols. All right, so no big deal. If you have a simple absolute value equation like this, write it once without the symbols and just go with that, and then write it again and flip the 1 to a -1. So now we solve both parts. Move the 17 over. I'm going to get 9x equals 18, and x is 2. Here I'm going to move the 17 over and get 9x equals 16, and x equals 16 ninths. And I don't believe that'll simplify, so 2 and 16 ninths is my solution set. Okay, now I don't think that we've solved any equations that you've never solved before, but I just want to get a nice good start on solving equations because we are going to solve them all year long. And always keep in mind that first definition. What does it mean to solve an equation? To find the value or values that make it true. And you will see that again and again. Every section we get to, we'll be solving equations. All right, so that'll do it for section 1.5. Young out.